Hello everyone, I'm EICN Ratnavardhana. I'm here going to speak about wireless network technologies. First we look at the protocols. Protocol is a collection of rules that govern data communication. It determines what is communicated, how it's communicated, and when it's communicated. It has three elements. First one is syntax. It contains the structure and the format of the data, and also indicates how to read the bits. The second one is semantics. It interprets the meaning of the bits, and it holds which field define what action. The third and final one is the timing. It assures when data should be sent and what data should be sent, and it also considers the speed. Let's talk about standard bodies. Standard bodies are organizations that create standards. For an example, we can get International Organization for Standardization, ISO, and ITUT, International Telecommunication Union, Telecommunication, ANSI, American National Standard Institute, likewise. And there are forums. Forums are small groups who are interested in creating standards and agreements from these organizations. Let's talk about ISO OSI 7 layers. A network is a collaboration of several hardware devices. Hardware devices can be manufactured by different vendors, so there should be a standard to establish the communication among them. As a solution, ISO has introduced an open systems interconnection OSI 7 layers. The first one is physical layer. Physical layer interacts with the transmission medium and the hardware involved, and it encodes of the bits to signals, and it's happening in this layer. The other one is data link layer. Data link layer transmits frames containing data with control information. It involves in error control and flow control. In the network layer, it provides routing and relaying over the subnetworks. Effective, where the end-to-end path consists of series of tail links. In transport layer, it provides a reliable end-to-end transfer of data. Multiplexing, splitting, and segmenting are happening here to transfer the data efficiently. In the session layer, provides a mechanism for opening, closing, and managing a session between user application process. In the presentation layer, is responsible for delivering and formatting of information to the application layer for further processing or display. Data is unprocessed data that can't be transferred through a transmission medium. To transmit the data through a transmission medium, we have to convert them into signals. The analog signals has certain characteristics. The first one is peak amplitude, is the value of the highest intensity of a signal. The period is time which a signal takes to complete a cycle in seconds. Frequency is a number of periods happening in 1 second. Phase is a position of waveform relative to time zero. Time domain is a representation of amplitude in a signal with aspect of the time. The frequency domain is a representation of signal amplitude with the frequency. The bandwidth is a range between the upper and lower frequencies in band of frequencies. It's measured by hertz. It is highly significant for determining how fast a web page loads in a browser. It is also one of the essential things to consider while you are choosing a platform for web hosting. The bandwidth can be significantly affected by the website and the internet connection used for accessing it. Generally, a website loaded with heavy graphics will need higher bandwidth. Similarly, a simpler website will require comparatively lesser bandwidth. Just as fast internet connection allows you to download web pages and videos flawlessly, higher bandwidth will effectively improvise the user experience and let your users avail the very best from your website. In digital signals, there are certain characteristics. Bit interval is the time required to send a single bit. Bit rate is the number of bits that can be transferred in a second. In transmission impairment, there are three things happening. The first one is attenuation, that is a reduction of signal strength which travels through a medium. The second one is noise, that is unwanted modification for a signal that happens when the signal travels in a transmission medium. And the third and last one is the distortion, that is alteration of the signal to the alteration happens to the signal shape of a waveform. In digital transmission, there are certain methods we can do. In the line coding, that's a line code that uses data transmission of a digital signal over transmission line. It has three types. Unipolar is the first one. Unipolar signaling is also called one-off keying. So the presence of pulse represents as 1 and the absence of pulse represents a 0. It has two types. First one is non-resident 0. Their high in data is represented by a positive pulse called a mark. The low in data input has no pulse. In unipolar return to 0, same as above, high in data is represented by a positive pulse called a mark, and this half of the bit duration remains high, but it intermediately returns 0 and shows the absence of pulse during a remaining half of the bit duration. In polar, there are two types. Polar NRZ, that is high data is represented by positive pulse, while low data is represented by a negative pulse. In polar returns 0, same as above, high in data is represented by a positive pulse called a mark, and half of the bit duration remains high, but it immediately returns to 0 and shows the absence of the pulse during the remaining half of the bit duration. And the bipolar method, it is an encoding technique which has three voltage levels, namely positive, negative and 0. Such a signal is called as duo binary signal. For a 1, the voltage level gets transitioned from positive to negative or from negative to positive. Having alternate ones to be of equal polarity, that's happened like this. That is a 0 have a 0 voltage level. It has two types: bipolar non-return to 0 and bipolar return to 0. From the methods so far discussed, we have learned the difference between non-return to 0 and return to 0. It just goes in the same way here too. There's another method called inverting null into 0. There, if the binary representation is 1, there is a voltage variation. If the binary is 0, there is no difference happens to voltage levels. In the digital transmission, when we convert analog signal to digital, there is a method called pulse code modulation. That method used to convert a digital signal to a digital signal. Here the amplitude of the analog signal is sampled regularly at uniform intervals, and each sample is quantized to the nearest value within a range of digital steps. As I mentioned, PCM has 3 steps: sampling, quantizing, and encoding. At sampling, the analog signal is sampled into several sections against time. After this process, the signal is called the pulse amplitude modulated signal. In quantizing, the samples are divided into many discrete levels. After each individual sample is numbered according to the corresponding levels. There can be some very tiny differences between the quantized level and the actual amplitude. That is called quantizing error. This affects the signal to noise ratio at the receiving end. According to that, we can say that higher amplitude pulse will have higher signal to noise ratio, and small amplitude pulses have lesser signal to noise ratio. To avoid that, nonlinear quantizing is introduced. That is, using nonlinear quantizing, we can maintain the same signal to noise ratio for all pulses. In encoding, the quantized levels are represented as binary numbers. It turns quantized amplitude values into binary values. In modulation, it's a technique used to send information by modifying the characteristic of basic electromagnetic signal that happens there. The basic signal is called the carrier signal. The characteristics of the signal are amplitude, frequency, and phase. It involves modulating signal and carrier signal. Once the carrier signal characteristic is changed, it is called modulated signal. If the modulating signal is an analog signal, it's called analog modulation, and if it's a digital signal, it's called digital modulation. And there are certain methods to do the digital signal to digital signal conversion. The first one is amplitude shift keying. It's a method of digital to analog conversion. And it's a type of modulation by amplitude. In a conversion, amplitude gets higher value for binary ones, a 0 for zeros. In frequency shift keying, frequency gets into higher values for positive values and low frequency for zero values. In phase shift keying, the phase is changed for the binary value. This has 2 types. The first one is binary phase shift keying. It uses phases which are separated by 180 degrees. And the second one is quadrature phase shift keying. The input signal divides into 2 parallel streams. These bit combinations will have 4 different phases. That is 0 degrees, 90 degrees, 180 and 270 degrees. When the analog transmission, analog signal to analog conversion, there are certain methods. Amplitude modulation, that is, The amplitude of the carrier signal varies according to the amplitude of the modulated signal. In frequency modulation, the carrier signal frequency changes according to the amplitude of the modulating signal. In phase modulation, the carrier signal phase changes according to the amplitude of the modulating signal. In multiplexing, there are certain methods to do multiplexing. When we speak about synchronous TDM, the synchronous TDM works by the multiplexer giving exactly the same amount of time to reach to each device connected to it. This time slice is allocated when if the device has nothing to transmit. It is a wasteful because there will be a number of time a line is not used in a channel. Therefore, no guarantee of getting maximum usage of efficiency. In statistical TDM, the concept behind that is similar to the division multiplexing. Similar to time division multiplexing. Additionally, it analyzes statistics related to the typical workload of each input device. Based on the measured statistics, it identifies the time each device should be allocated. This method of multiplexing uses channel bandwidth more efficiently than synchronous TDM. And orthogonal frequency division multiplexing is a method of digital signal modulation in which a signal data stream is split across several separate narrowband channels at different frequencies. It is used in Wi-Fi, DSL, Internet access, 4G wireless communications, and digital television and radio broadcasters as well. Frequency hopping spread spectrum is a method of transmitting a radio signal by rapidly switching a carrier among many frequency channels using a pseudo random sequence known to both transmitter and receiver. Each available frequency band is divided into sub-frequencies. Signals rapidly change among these in a predetermined order. Direct sequence spread spectrum is a transmission technology used in local area networks, wireless network transmissions. In this technology, a data signal at the sending station is combined with a high data rate bit sequence, which divides user data based on spreading ratio. In transmission media can be mainly divided into two categories. First one is guided transmission media and the other one is unguided transmission media. Twisted pair copper cables and fiber optics fall into guided media. Twisted pair reduces the bit error rate by twisting the cable, which increases the immunity of the electrical noise. Fiber optics are made of glass fibers. It has very high performance for long distance traveling. Like that. Unguided media represents domestic radio, satellite communication, and mobile radio. There are ARQ, automatic repeat request method as well. ARQ is a simple way of distribution and getting information. The receiver sends an acknowledgement regarding the information received. For correct information, sends positive acknowledgement, and incorrect information get a negative acknowledgement. Stop and wait ARQ. Transmitter sends information and waits for the acknowledgement. If it's possible, if a positive received, sends next information. If a negative received, sends back the message again. In continuous ARQ, transmitter keeps sending information continuously until negative acknowledgement, which is NAC, returns. There are certain error detection and correction methods. The forward error correction method is called it contains redundant bits add to the original data. Using the redundant bits, it detects the error but it contains redundant data. That is a disadvantage of that. And in the random access methods, there are two. There's a common method called Aloha. That is the earliest random access method. It has two versions. First one is pure Aloha. It allows stations to transmit data at any time whenever they want. After transmitting the data packet, station waits for some time. The second one is slotted Aloha. Slotted Aloha divides the time of shared channel into discrete levels called time slots. Any station can transmit its data in any time slot. The only condition is that station must start transmission from the beginning of the time slot. If the beginning of the slot is missed, then the station has to wait until the beginning of the next time slot. A collision may occur if two or more stations try to transmit data at the beginning of the same time slot. In ESMA CD, any device can try to send a frame at any time. Each device senses whether the line is idle and therefore available to be used. CSMA CD, unlike the CSMA CA, unlike the CSMA CD, which deals with transmissions after the collision has occurred, CSMA CA acts to prevent collisions before they happen. Here, as soon as node receives a packet that is to be sent, it checks to be sure that the channel is. If the channel is clear, then the channel is sent. If the channel is not clear, the node waits for a randomly chosen period of time and then checks again to see if the channel is clear. This period of time is called the backoff factor and is counted down by the backoff counter. If the channel is clear when the backoff counter reaches 0, the node transmits the packet. If the channel is not clear when the backoff counter reaches 0, the backoff factor is set again and the process is repeated. In the frequency division, multiple access is one of the most common analog multiple access method. The frequency band is divided into channels of equal bandwidth so that each conversion is carried on a different frequency. In TDMA, it allows multiple stations to share and use the same transmission channel by dividing signals into different time slots. Each user uses its own time slot. That's the end of my presentation. Thank you.